In this example, I wanted you to find a real-life situation in which you will see a sinusoidal function or cosine rule used. I use an example that I found at page 7 and 8 of this URL, and I added some questions that you will see below in a few seconds. So here's the problem. As you ride a Ferris wheel with 12 seats, your distance from the ground varies with time. You sit at some unknown height, so you are here, you are unknown height from the ground at the start. It takes you 42 seconds to reach the top, 30 meters above the ground. So when you're here on the top, it takes 42. The wheels makes one revolution every 72 seconds. So that means for one turn, it takes 72 seconds. And the radius of the wheel is 14 meters. So I encourage you to to sketch quickly this Ferris wheel, and we'll put the information on the graph. I shouldn't say on the graph, I should say on the diagram. So you are here, and it takes 42 seconds to reach the top, and it's going this way, as you can see. So it takes 42 seconds to reach the top here. And when you are at the top, you're going to be 30 meters from the ground. So you can see that here, 30 meters is to reach the top from the ground all the way down here. You see that there's a boarding platform at the bottom here, so we're gonna have to figure out what here is the height of the boarding platform here. And the radius of the wheel is 14 meters, so that means that the radius here is 14 meters. So now if we look at the questions, first question, how high is the boarding platform? So this is for a question A here. How high is the boarding platform? So if the radius is 14, there's going to be another radius down here, another 14 down here. So you can calculate, you can do 30 minus 14 times 2, so minus 28. So you can figure out that your boarding platform is really at 2 meters. Second question, draw a graph to model the height above the ground at key points. So this is not easy to graph. I will show you a quick sketch here, but then I will show you a complete graph after. So if you're going to sketch this, you need on the x-axis the time in second, and you need on the y-axis the height in meters. You know, at the beginning, you're at an unknown distance from the ground, so we cannot write that down, but we know that at 42 here, at 42 seconds, you are going to be at the top, which is 30. So we can come and put a point up here. And you know that it's going to go down and back up again. It's going to repeat 72 seconds later. So you're going to have another top here, 72 seconds later after your 42. So 42 plus 72. You can write down here 114. Sorry for my writing. And so that's the top. Halfway between 72 and 40, and between your 72 seconds, halfway you're going to be down at the bottom here. So if you take your 72 and you divide by 2, you get 36. So if you do 42 plus 36, you're going to find out when you're going to be at the bottom. So at 78, exactly here, you're going to be in the middle, here at 78. You're going to be at the bottom, and the bottom is here at 2. If you start from 42 and you go back 36 seconds, you're going to find the other minimum, which is going to be 6 here. At 6, you're going to be at the minimum. So you can see already that you have your minimum and your maximum. Where is going to be the sinusoidal axis exactly in the middle? So you can take 30 plus 2 and divide that by 2, and you get your 16 here. And so what happened in the middle of 30 and 2 here? Sorry, the middle of 42 and 6. 42 plus 6 is 48 divided by 2 here in the middle. That means here at 24, you're going to be in the middle. And the same you can do here in the middle. So you can start sketching your graph. Okay. Take a few seconds to try to finish up your sketch, and it should look like this. You can pause the video to make sure your graph is on scale. Let's look at question C. What is the period and what does it represent in this situation? So the period here is how long it takes to repeat. So it's 72 seconds. And what does it represent in this situation? It represents the time that the wheel needs to make one turn. What is the value of K and what does it represent? In this case, K is 16, is your sinusoidal axis. What does it represent? It is really the height of the middle of your wheel here. So that's your K. How high is the center of your wheel? Question E is asking what's the amplitude and what does it represent in this situation? Here the amplitude is this height here, or from here to here. So from 16 to 2 or from 30 to 16. So the amplitude is 14. And what does it represent in this situation? It is the radius of the wheel. Find the sinusoidal equation that models your ride on the Ferris wheel. So if you remember, the general rule was y is equal to a sine b bracket x minus h plus k. So we need to find what is a, b, h, and k in this situation. So if I look at the graph, if you remember, sine looks like this. So it starts here, goes up, down, and comes back here. So on my graph, I could identify where is the middle. Here, this is my K. So my sine would be here. I highlighted it in yellow so you can see it. So when I looked at my graph, my H would be my starting point. So H is the number here, and we calculated before it was the middle between 6 and 42. It was 24. So that would be my H. My H is 24. Your K is this one. K is 16. Your amplitude, we talked about it. It was here. So A is 14. And B, if you remember how to calculate B, B is equal to 2 pi over the period. And the period was 72. Now we can simplify this. If we divide by 2 up and down, it would be pi over 36. So if we come back to write down our rule, the rule would be, we could actually use h for the height. It could be h is equal to 14 sine of pi over 36. And we're going to use t for time. T minus 24. And then plus 16. Now they want to find the y-intercept and what does it represent in this situation. So if I look at my graph, the y-intercept is really this point here at the beginning. So how do we figure that out? The y-intercept is the y value when x is equal to 0. So now that we have a rule, we can just plug it in here. We can plug in our x value or t value for 0, and then you just have to type that into your calculator. Make sure your calculator is in radian or rad, because your angles are in pi over 36. It's a rad angle. So if you plug in 0 in your rule here, then and you type all of this, try to type it all at once in your calculator, you should get that your initial is about 3.88 meters. What does it represent in this situation? It's the height of your seat at the beginning of the Ferris wheel ride. Now, last thing, could you write your equation 3 other ways using at least sine and cos once? So we already used sine here. So if we want to use negative sine, so remember this is the rule for sine. Negative sine would look more like we start from here and we go down and back up. So do you see where we would start to identify a negative sign? We could start here, go down, back up, and then later on it's going to go here. So the h will change for this one. H would be equal to 60. Everything else remained the same. So when we write our rule, it would be h is equal to 14. Sorry, negative, because we said we're going to use a negative sign. So negative 14 sine of pi over 36, and then t minus 60 plus 60. Now if we want to use the rule in cosine, I'm going to start again with my graph, but you have to remember that if we use cosine, cosine starts at the top, comes down and back up. So if you look at your graph, where would we start for cosine? We're going to start at the top, go down, and then it's going to go up later on here. So that means that our h is the starting point here. If we come down here, what is the graph? H is equal to 42. They told us in the problem that's at the beginning, sorry, when it reaches the top, it's at 42 seconds. So we already knew that from the problem. So we can write our rule. A, B, and K are staying the same. So it's going to be 14 cosine of pi over 2d6 t minus 42 plus 16. And the last rule, try to do it yourself. If you want to do a negative cosine, remember that negative cosine starts, instead of starting at the top, starts at the bottom. So imagine that you start at the bottom, you go up and down like this. So if you look at your graph, you could start at the bottom here. It would go up and then down here. So that means that your h is going to be this point here at the minimum. H is going to be 6. So when you want to write down your rule, it's going to be h is equal to 14, sorry, negative 14 cos pi over 36, which is still the same, t minus 6 plus 16. There are more problems in this document, so if you want to go find out that URL, you can see other problems about real life situation. Have fun!